Hello again. Welcome to another lesson in Algebra 1. Today we are covering section 6.3, solving and graphing solutions to inequalities. We have a warm-up first. So graph the solution set for each inequality. So number 1 says x is less than -4. So that means that all of our solutions, there's everything that is smaller than -4. So I put a circle on -4. Remember, I don't fill it in because -4 is not one of our solutions, but every point to the left of -4 is smaller than that. So all of these things on this shaded line are smaller than -4. Okay. Number 2, this says 3 is less than or equal to x. So 3 is smaller than all the solutions, but also 3 is equal to a solution. So I'll put a filled in circle on 3. And this says the solutions that are bigger than 3, or 3 is smaller than solutions. So things that are bigger than 3 are on this side. Okay. Notice this one had a filled in circle and the first one didn't, and that is because of the equal to bar. Okay. The first one shaded to the left because x was smaller than -4, so our answers were smaller than -4. And this one shaded to the right because if we read this backwards, it says x is bigger than 3, so all of our answers are bigger than 3. Number 3, complete the sentence. We need to switch the inequality sign when we multiply or divide each side of the inequality by a negative number. So when our inverse operation requires us to multiply or divide by a negative number, that's when we switch the inequality sign. So we change less than to greater or greater to less. All right, number 4, solve and graph these solutions. So first I'll do the distributive property since 3 divided by 3 goes evenly into the two things inside of the binomial here. So I'm going to get x. 6 times 1/3 will give me 2, greater than or equal to -1. And I'm subtracting 2 to both sides. So I get x is greater than or equal to -3. Remember, subtraction doesn't make any inequality switch ever. Okay? All right, so we need to graph this. So we're going to put a filled in circle on -3 because of the equal to bar. So -3 is one of our solutions. And it also says all the other solutions are things that are bigger than -3. So this side is all the numbers that are bigger than -3. Okay. Number 5. Is -21 a solution to the inequality in exercise 1? Why or why not? So let's look back at exercise 1 for a second. Exercise 1 is x is less than or equal to -4. Now -21 is going to be way out here somewhere. It's going to be in our shaded region, so it will be a solution. Okay. So this is yes. -21 is in the shaded region. Because, and let's read the inequality one more time and replace x with -21. -21 is less than -4. Because -21 is less than -4 is a true statement. Okay, so there's two ways to tell. You could substitute in for x, which we did in this part, and see if it's a true statement, which it is, or you could just look in the shaded region if you happen to have a graph. Okay. All right, this concludes page 1. All right, page 2 starts off with something up top. It says the number of solutions. It says if the inequality is equivalent to an inequality that is true, such as -3 is less than 0, then the solutions of the inequality are all real numbers. So if I try to solve for x and all the x's go away and I end up with a true statement, just like before when we were solving for equations, we say all real numbers. Okay, so there's a lot of more ways than just the same number on both sides now. If an inequality is equivalent to an inequality that is false, such as 4 is less than -1, 4 is definitely not smaller than -1, then the inequality has no solution. So when we were doing equation solving, we did the same thing. When we had some stuff with x equals some stuff over here and we solved it, we end up with 5 equal to 2. We wrote no solution. Okay, put a little x there to show it was wrong. Or if we ended up with 5 equal to 5, we put a little check mark there and said all real numbers. Well, we're doing the same thing here. except in this case, we're looking for inequality signs instead of equals in between them. All right, so graph inequality with solution of all real numbers. All right, so in this case, notice the whole thing is shaded. Okay, it's not a really fat number line. It just says, hey, look, everything is a solution. So notice the whole number line is shaded here. And here's a graph of inequality with no solution. And notice that nothing is shaded. We have a completely blank graph. Okay. All right, solve each inequality possible, graph your solution. So just like when we solved equations that could have had no solution, one solution, or infinite solutions, we put these words if possible here. Okay. All right, so number one, first I'll subtract 5x from both sides, or 3x from both sides. Either one is possible. I'm going to do the minus 3x. This will give me 2x minus 12 is less than or equal to negative 4. And then I'm going to add 12 to both sides. So I'm going to get 2x is less than or equal to 8. And then I'm going to divide by 2 to both sides. And I'm going to get x is less than or equal to 4. So this solves just like normal. We have variables on both sides, but when we were done, we ended up with an x still left in our problem. So this has a solution set of the circle on 4, completely filled in because it's an equal to bar on 4. And then it says everything's smaller than 4, so we shade to the left. These are all the numbers that are smaller than 4. All right, number 2, first I'll do the distributive property. So I'm going to get 5m plus 25 is less than 5m plus 17. And then I'll subtract 5m from both sides to try to get all the m's on the same side. But just like before, something special happens. All the m's cancel out. We look at what remains and we say, oh, is this a true statement or a false statement? Is 25 smaller than 17? Nope, so no solution. And the graph for no solution looks just like this. We're done, okay? Remember, no solution means that there's no place that's a solution, so we can't plot any points on our graph. Number 3, same thing. I'll do distributive property on the right side. So I get negative 8z plus 4. And then I'm going to add 8z to both sides to try to get all the z's on the same side. And then that special thing happened where all the z's cancel out. And we look at what remains. And we say, is that a true statement? Is 1 smaller than 4 or equal to? And this is, yes, it is. So our answer is all real numbers. Okay, in which case we shade the entire graph because everything works. Okay. This concludes page 2. On our last page of notes here, we start off with it says translate each phrase to a math symbol. Okay, the bottom 2 we've talked about already. Those are less than and greater than. Those are easy to remember. Remember our trick with less than, so we know which one it is you hold up your left hand. Okay. And you make an L with your thumb and finger, and then you lean it over a little bit and you'll get less than. All of them start with L, okay? Now at most and at least are a bit trickier. At most sounds like you really want it to be greater than or equal to, but it's actually the opposite, less than or equal to. And at least is greater than or equal to. And if you think about this in terms of money, if I said I have at most $20, that means I have 20 or less, okay? I've got at most 20. Oh, that's the most I could pay is 20. That means I can't pay more than 20, so it's going to be less than or equal to 20. Same with at least, okay? The opposite way. All right, now write and solve an inequality to find an answer to each. Number 4 says you can work at most 24 hours per week as a nurse's aide. So far this week, you have worked 7 hours. If the remaining shifts for the week are each 4 hours long, how many possible shifts can you work? Okay, so our variable is told in the end here. How many possible shifts can you work? S is equal to number of possible shifts. Now, obviously, we can't go and work half a shift. We have to work the whole shift. And so far, we have worked 7 hours. And we're allowed to work 4-hour-long shifts, so we can work as many 4-hour shifts that will fit into our fact that we can work at most 24 hours. So we say less than or equal to 24. I have at most 24, so I have less than or equal to 24. Okay, I solved this equation or inequality. subtract 7 to both sides. So 4s is less than or equal to 17, and then divide both sides by 4, and s will be less than or equal to 4.25. So like we said before, we cannot work a partial shift. I can't go in and work one of the 4 hours because who's going to work the other 3? And they have to pay me to do a whole shift. So we can work, let's see, less than or equal to 4.25. So we can work, these are all the possible shifts. We can work 0 to 4 shifts, inclusive. Inclusive means including the outside numbers. If I said exclusive, we wouldn't count the 0 and 4. But here we could work 0 shifts, and that would be fine. We wouldn't go over our maximum hours possible. We could work up to 4. Okay, so 4 times 4 will give me 16, plus 7 more will give me 23. That'll be less than our 24 total possible hours we're allowed to work. Okay, so 0, 1, 2, 3, 4 are all of our answers. All right, our last question. You are saving money for summer camp that cost $1,800. You have saved $500 so far, and you have 14 more weeks to save the total amount. What are the possible average amounts of money that you can save per week in order to have a total of $1,800 saved? So at least $1,800. All right, so we're going to be saving money each week, an average amount. So we just want to say this is what we'll save every week. Okay, so we're going to say money equals amount saved each week. Okay, we know we want to have at least 1,800, so at least is greater than or equal to 1,800. And let's go back. How much did we start with? Well, we've already saved $500. And we're going to save some more money every week. Well, how many more weeks are we going to work at it? 14 more weeks of saving. So we'll solve this inequality. Okay, so first I'll subtract 500 from both sides, and it'll give me 1,300. And then I'll divide both sides by 14. And 1,300 divided by 14 makes about 92.857142 with a bar. Okay, now that doesn't make any sense in terms of money. So we're going to need to save at least $92.86. We'll round to the nearest penny there. Okay, we only need 2 decimal places to get to pennies. So what are the possible average amounts? We must save at least, because I can save the minimum amount here, at least $92.86 each week. Okay, so this is an average amount, so we must save at least $92.86 each week. We could save more, so that's what the at least part in this sentence is for. Okay, so we could save $92.87. We could even save $98, and of course then we give extra spending money when we got to summer camp. Okay, all right, this concludes today's notes. If you look on our last page, you have a follow-up. There are 3 questions here. 2 of them are solved if possible. And the last question is one more word problem. There are, of course, 3 answers here, but do more than just copy the answer. You need to try it yourself, and that lets you know if you know what's going on, or if you need to go back and rewatch the notes and do some more learning. I'll see you in class next time.